Well, quiz 3. Quiz 3, of course, is all about effective interest rates. And these you do run across all the time. As you recall, I mentioned in class that by law, banks always quote the annual percentage rate. This is true in all industrialized countries. Then they also give you the compounding period, and often they will quote you the effective rate. In fact, more and more that's being required because most people don't understand the effect that compounding has on the interest rates. Well, we start out with two basic problems. The first one is you've got a 6% annual percentage rate. Remember, that's simple. Two different compounding options, fine. So the first one is 6% annual, compounded quarterly. I asked for a three-digit answer here, of course, because that's really where we start to see the difference on something like this. So let's just do it quickly. It's 6% compounded quarterly. Well, all right. Oops, I've got to go to the pen mode. I was in the pen mode, but now it didn't seem to want to give me back to the pen mode. So here I'm back in the pen mode. All right, 6%. Well, our formula is we take 1 plus. Well, it's 6%, and it's going to be compounded quarterly. So in 1 quarter, we have the 6% divided by 4. That's how much interest, simple, is in that quarter. But it's compounded 4 times, so we have to take it times a fourth. And then, of course, if we want the interest rate, we have to subtract the 1 off and express it as interest. And so we actually take that by 100%. I generally won't bother to write the 100% down. I wanted 3 digits, so you wind up with 6.14%. And of course, that's what you generally are looking for. The bank is looking for. That's why they compound it, and that's why it's quoted that way, is because most people won't understand the difference between the 6% and the compounding. Well, the second says it's compounded weekly. Well, same idea. Now we've got 1 plus, only now it's 0.06 divided by 52 weeks in a year. So that's how much interest 1 week would get in a simple sense. And we are going to compound it 52 times. We have to take off the 1. And like I said, I'm not going to really write down. By the way, I should write this as 1A. And this is B. And that's times 100%. And so now I get 6.18%. 6.18%. Not a huge difference, but of course, as we get to higher interest rates, there will be progressively more of a difference in the numbers. But still, it's costing us more the more we compound it. Well, let's look at number 2, problem 2. Problem 2. How much we have at the end of 9 months, 36 weeks is what we're going to assume, 9 months, if you deposit $100, 14% compounded weekly. Well, we're compounding 14% weekly. Okay, well, again, this we always assume is a simple rate unless we're told otherwise. And so this is 14% annual, and so we have to convert that. All right, so let's go number 2. Oops. When I have the pen apparently in this mode, I have to keep refreshing it every time I change. Well, that's okay. All right, so number 2. What do I have? Well, I have $100. I'm earning interest on that, and the interest I'm going to earn on it, well, all right. I have, what did I say for interest? I have 14%, and I'm going compounded weekly. I'm going 9 months. Okay, 14%. That means my weekly amount, my weekly interest is going to be 1 plus 0.14 divided by 52 That's how much interest for each week. But I'm compounding that for 9 months, or I said 36 weeks, so 36. And so I'm going to wind up with $110 to 3 digits. So I've got $110 when I do it that way. That's A. There's a part B too. And the part B says, what if it's compounded continuously? Well, I don't know if banks do that as much anymore. It used to be pretty common to talk about. I haven't heard much about it lately. But continuous compounding, well, if you remember continuous compounding, that's where we get the exponential, the natural exponential function. But we have to know how many compounding periods in a year. Remember, we want e to the rate divided by k, where this is the number of periods, compounding periods in a year. Well, what's k? Well, k, in 1 year, there's 12 months divided by 9 months. That's how many compounding periods. There's 1 1/3. So our factor here for the interest rates becomes e to the interest rate 0.14 times 12 over 9, excuse me, not times, divided by 12 over 9, or e to the 9 times 0.14 divided by 12, and I got that. And of course, if we want the interest rate, let's compute the interest rates first. Well, that's right, I get 1.111. So it's 11.1% is what I get in 9 months. If I compound one year, and I want to know at the end of 9 months out of 12, so that's how much I get for that year. I don't get, so the 14% now leads me to 11.1%, and so my the amount I have to go back and pick up my pen again, that's right. The amount of money I have then is going to be $100 times that, so I have $111. That's how much I have in 9 months with compounding continuously. A little more, not a lot. We've noticed that before when we looked at it in class, that compounding periods make a big difference for a little while. So there's a big difference between nothing and 4 or 5. But once you get 6, 7, 8, there's not much difference anymore between that and continuous, which is why for a while banks did continuous, because it sounded so good to everyone. It was a good sales point, didn't cost you much money. Well, number 3, last one. Let's look at problem number 3. Number 3, if you were to save $100 a month in an account that's compounded continuously at 10%, how much would you have in 2 years? So the first thing we're going to have to do is find out what is the monthly interest, because this is an annuity, right? We're putting in $100 a month. It's a 2-year annuity, or 24 periods, but we need to know the interest rate. So we start off, and let's find the interest rate first. Let's pick up my pen here again. The first thing is, what's the interest rate? Well, there's 12 compounding periods, so my rate is going to be E to the, what did I say it was a minute ago? I said it was 10%, 0.1. 12 compounding periods in a year, minus 1, expressed as an interest. And so if I express that, I get 0.84% per month. So not quite 1% a month is what I'm going to make on it, about what you'd expect. And so my future value, it's a future value problem, is, well, it's $100. It's how much I put in a month. It's a function of the future value over the annuity. Interest rate is 0.84%. And it's 2 years, so it's 24 periods. And so that's we'll just write it out this time. 100 times 1 plus 0.0084 to the 24th power minus 1 divided by 0.0084. And what did I get? I got to 3 digits. 2,000. Let's move this over. $2,650. It's actually 2,647, but to 3 digits I rounded off to 650. So that's the answer for number 3. Well, I hope you all got this. Wasn't meant to be tricky. I'm going to write this just a little more neatly this week, I think, and then I'll scan it and I'll put this up as well. We will continue on and we'll talk a little about investments, stocks, bonds, and what some of the experience and options and that sort of thing are next time. In the meantime, you take care. Bye now.